Hi guys, so today we're going to be going through a soil mechanics question on one-dimensional seepage, and as we know, one-dimensional seepage calculations help us better understand the flow of water through soil. So let's start off by writing out and drawing a diagram of the information we're given. So here's the water surface of the lake, and we don't know the depth of the water, so that's what we have to figure out. We're given the fact that there are two piezometers installed, one at a depth of 2 meters below the lake bed surface and one at 5 meters below. We're given the pore water pressures of these piezometers, 85 kilopascals and 94 kilopascals. Okay, and then here's the surface. Okay, we're asked to find this height of the water or depth of the water. Now, we know that pore water pressure varies with depth. This means we can actually find, we can graph the relationship between pore water pressure and depth. So pore water pressure would be going this way and depth would be going this way on this axis. So 0 meters, 5 meters. And we know that at 5 meters, the pore water pressure is around 94. And there's a certain amount of pore water pressure at 0 meters as well. Now, this will be a linear relationship since it's only one type of soil that we're looking at. We know that at 2 meters, we have 85 kilopascals of pore water pressure. Okay, so now we can already see that we have a similar triangle sort of situation going around here. Okay. But we're not going to get to that right just yet. What we're going to do is we're going to find the linear equation or linear relationship of this slope. How we're going to do that is we know that the equation of a line is y equals to mx plus b. Okay. Now, we know that the gradient can be found by rise over run. So the rise over here would be 3. Remember, this is not to scale. Just thought I'd note that. And this difference here is 9. So the gradient equals to negative a third. Okay, because it's negative 3 over 9, so negative a third. And we can substitute a point, and this point will substitute. So think of it as if it's in the Cartesian plane. So say we substitute this point. This point would be 94 and negative 5. Okay. If we do that, we can find what b is equal to. So we say now we can rearrange this equation and we will get, which gives us 26.333, so on. Therefore, we get our line equation, which is y equals to negative a third x plus 26.333. Now, what we want to know is the pore water pressure at 0 meters. Why? Because this would allow us to use the relationship U equals to gamma W times H. So if we know U, then we can figure out H, since we know that gamma W is 9.8. So to do this, to find the pore water pressure at 0 meters, we just have to substitute y equals 0. So we get 0 equals to negative a third x plus 26.33. And rearranging this, we get x equals to 79. Therefore, we can say that the pore water pressure is 79 kilopascals. Now we can substitute this into that equation and we get 79 equals to 9.8 times H, and therefore H, or HW, is 79 on 9.8, which equals to 8.06 meters. And that is our answer. Sorry. There you go. Okay. Hope that made sense. Okay, so the next part of the question wants us to find the effective stress at a point located 2.16 meters below the lake bed. So let's plot it. Say it's around here, and this is 2.16 meters below the lake bed. Now, what we're going to do this time is we're going to plot the pressure head versus depth, because there's a few things to note here. We can use the relationship U equals to gamma W times HP, pressure head. And we also know that we need to find U, because to find the effective stress, we need to subtract U from the total stress. So this is the relationship we need to use. Now, our total stress, we know that we use gamma Z. So we're going to use the pressure, the depth that we found from the previous question, times the gamma, which be, since it's just water for that layer, water layer, it'll be 9.8. Now we need to also consider the layer below over here. Now we're given that the wet unit weight, as we know, that's the surface below the lake bed would be saturated with water since there's water above it. So we're going to use the wet unit weight, and that's given as 18. So our gamma here is 18 for this layer, and our depth is 2.16 because we're looking at a certain point. This gives us a total stress of 117.88. Now, we want to know what the HP is at 2 meters and at 5 meters below the lake bed. At 2 meters below the lake bed, we can use this relationship to find it. So the pressure head at 2 meters below the lake bed would be 85 over 9.8, because we're using the relationship HP equals to U over gamma W. It's just rearranging this one. So that gives us 8.67. So we can plot this here as 8.67. And the pressure head at 5 meters below the lake bed is 94 over 9.8. And that gives us 9.59. So now we know that the difference here to here is 3. Again, it's a linear equation because we're only dealing with one type of soil. And this distance here will be 9.59 minus 8.67. And that gives us 0.92. Now, we asked to look at the HP of the specific point, 2.16, so that we can find U and so that we can find the effective stress. So let's just say, again, this is not to scale, but let's just say 2.16 around here. We need to find this, the HP here. Now, we can use similar triangles. As you can see, we're developing a similar triangles situation here. Okay. Now let's call this section A. Okay. So, by similar triangles, we know, okay, so, and also note that this distance here is 2.84. Okay, so now it's just a matter of similar triangles. A over 2.84 is equal to this 0.92, this difference here, over 3. Rearranging this, we get A equals to 0.87. So therefore, we know that our HP at our point X would be this total subtracted by A. So our total here, 9.59, from here to here, from here to here, right? And then minus A, which is 0.87. and we get 8.72. Now this is very easy because all we can do now is find the pore water pressure here, which is 9.8 times 8.72, which gives us 85.45. Okay, so that's the pore water pressure at the point X, the specific point. Therefore, the effective stress is 117.88, which is the total stress, minus the pore water pressure. And that gives us 32.43 kilopascals. And that's it. That's our answer. Okay, so that's basically how to do this sort of question. Of course, there's more complicated versions of these questions, of one-dimensional seepage questions. I do hope that I covered it properly, and that it was easy to understand. I do understand that my voice is quite shaky. This is my first video, so please forgive me if this isn't the best. Feel free to leave constructive criticism in the comments so I can improve next time. And yeah, I'll try to do some tougher questions in the future. But for now, just feel free to smash like, subscribe, and I'll see you again next time. Take care.